Okay. Intermediate value theorem. Tell me this. Where do you want to go on a trip?
Hawaii.
Oh, good choice.
Australia.
Okay, so you get on an airplane, right?
Right now.
And you're in Denver, and you get on an airplane, and you get up to altitude, and you fly, and then you go to Hawaii, and you land, and you have the time of your life, right? Is there, if this is a direct flight,
There's no direct flights.
okay, is there any point during the flight where you get to skip a mile?
No.
Can I skip that mile?
No.
Why not?
Because you would have to stop and you can't. You're in the air.
You'd have to teleport, and we're not that cool, right?
Yeah.
Okay.
Yes.
Okay, no teleporting. This is basically the intermediate value theorem. This illustrates the concept, okay, that you can't skip any values. Okay, you know that your plane flight is continuous, right? So there are some conditions. It's continuous, meaning
Although
I didn't stop in San Francisco.
if you're going backwards into the international date line, your time switches.
But the total time that you've traveled doesn't. But
Okay. Well,
yes, you skip a day, right?
yeah, if you do it,
It's weird.
right.
Okay, so it's continuous. We know that every value in here exists. Okay, we can't skip values. That's the concept of the intermediate value theorem. Here is the actual statement. It's called the IVT. If f of x is continuous on a closed interval, AB. Now, you don't have to say on a closed interval. You could just put AB, but we're being obvious here. And f of A does not equal f of B. Then, for every value, they call it M. It's a Y value. Okay. Between f of A and f of B, there exists at least one C in an open interval AB such that, yep. So we've made this really complicated out of really easy, right? Okay, so this is an X value, and this is a Y value. Okay, that theorem says the same thing that I just told you about the airplane ride. That you can't skip values. Okay, take a deep breath. Thank you to theoretical mathematics for that, right? I guess we'll find out. I don't quite know what you're asking, but okay, so basically, Right, so there's a picture. That's what this theorem is saying. So in this closed interval, I'll let you copy it down. Okay, in the closed interval AB, okay, notice that this has to be true. Those can't be the same point. If they were, there would be nothing in between them. For every value m that's between these two, it's a y value, there exists a c between a and b. And then f of c equals m. That's what that theorem says. So basically, you're finding an x and a y that match after you plug the function into the, or the x into the function. Okay. Okay, let's do an example. Prove. Good word. Okay, prove that sine x equals 0.3 has at least one solution. Okay, we are not looking for the exact number. We just need to prove that it exists. Okay, so look at the conditions here. Is sine x continuous? Okay. Check. So we can use the intermediate value theorem. All right, so be careful. If it's not a continuous function, you cannot apply this theorem. You just have to say we can, sine x is continuous. All right, so what do we know about sine at 0? Which one is it? Okay. What about sine at pi over 2? 1. Okay, the graph looks like that, and then it would come back down to pi, 0 at pi, right? That's sine. So at 0, it's 0. At pi over 2, it's 1. Okay, that's all we need. And we can make our statement. Is 0.3 between these two? Yeah. Okay, because sine is continuous, so on the interval 0 to pi over 2, right? So that's our x values, right? The intermediate value theorem says sine x equals 0.3 has at least one solution on 0 pi over 2. Yeah, you do need to write this out. And you have to show that that value is between those two. We don't need to know what x valued is. Okay, do you have the ability to find it for this one? Yeah, you do. Okay, but there are some more complicated ones that you won't be able to, that you just need to be able to say it exists. Okay. Okay. Easy enough on that one? Okay, here's another, a little harder. Let me go. Okay, here's an extension of the IVT. Okay, what do we know about this graph or the function if f of b is negative or positive and f of a is negative? What happens? Yeah, there's a 0. Okay, so we can confirm a 0 exists if f of a is negative. Well, f of a and f of b have opposite non-zero signs. Okay. So it can go the other direction too. But if the y values are above and below the x-axis, we know that there's got to be a 0. Okay. If f is continuous. It's their condition again. All right, so or let's not use that word. Let's say show minus Okay, are we asking you to find it? Find the 0. No, just say show it exists. Right, so yep, plug it in. Okay, first of all, is it continuous? How do you know that?
Because of that theorem of erasing cosine and sine.
Yes, both sine and cosine are continuous, so therefore all the operations on them won't affect that. Okay. All right. So what's f of 0? Do you guys know how to rewrite cosine squared x?
Cosine x squared.
That's the same thing. Get that in your brains. So it's cosine at 0, which is 1, and sine at 1, sine of 0 is okay, that's positive, right? That's what we need to know. And then plug 2 in. And we're in radians. Remember, your calculators need to be in radians here.
It's what? Negative 0.786. So do we have a 0? Yeah. It goes from positive to negative. Something like this. Okay, so a 0 exists. Okay, do you want to figure out where it is? Estimate where it is? Okay. You're going to need to know. This is called the bisection method. Okay. What number between here would you use to split that in half? Okay, so let's try f of 1. What do you get? Anybody? Or are you just waiting for me to write it down? Yeah. Point to what? Okay. 3 spots is enough. All right, so this is a negative, right? So between 0 and 1, there's a sign change, right? Okay. Now let's do, we know it's in 0 to 1, so let's do f of a half to narrow that interval down further. Probably. Okay, what's f of a half? 0.521. That's positive. So we know it's between 1/2 and 1, right? What about 3/4? Do you see where I'm headed here? Is 0.163 positive. So it's between 1 and 3/4. Okay, try 7/8. 7/8 is negative. Is it? The sign change tells you the two numbers it's between. So let me write this out. No. Okay, you see this table I just built? Does that make it easier? I put them in order. It's between 3/4 and 7/8. Okay. So. So you could just state it something of that nature. Or you could say something like that. It's lots of ways to say that, but the key is to stay organized. So if you draw it in a table, it does help. Okay. So you get the idea of the intermediate value theorem. Points exist on continuous functions. Okay, lots of we're good. It's 2.8. 1, 5, 6, 8, 17. 19, 21, 22. And then some spiraling. 2.419, 38. There you go. Okay, 9's one of the harder, or sorry, 1, 5, 6. 8. 38. Put a star on 8. It's the harder one. All right.